Alright, so next bit of chapter is the thing that actually integration is used for, which is finding the area underneath curves. Now everything we've done so far is actually really everything we need for this particular part of the chapter. So we're not really learning anything too new here in terms of the mathematics that we've been doing, but just in terms of how this works. A bit like when we differentiate, and sort of the way we get into that is trying to find the gradient of a curve at a particular point, and if we move a tiny bit over, then actually that helps us, that tiny little increment. If we can just find like the straight line gradient between those 2 points on the curve as a straight line, and as long as that increment is very, very small, then we've got a really, really good approximation to the gradient at that point. And in fact, if the increment is so small as to say, well, it's pretty much zero, then we get a dead spot on gradient for that point. So we're going to do the same sort of thing for an area under a curve. So if I wanted to find the area between these 2 points here, effectively what I want to do is say, well, I want to make this difference in x really, really tiny. Okay, so I want a very, very small incremental difference in x. And if I do that, then what I can do is I can approximate the area just as a rectangle. So I can ignore the sort of the curve part, because this is such a small difference. Then I can ignore the fact that there's a curve and I can just approximate it with an area. So actually what I end up with is that the area here, which we can call the difference in the area, so dA, would be equal to, well, y times by the difference in x, because it's a rectangle. If I rearrange that, I can then say, well, dA over dx equals y. And then actually, if we have a look at this and say, well, if that is basically the area differentiated, how can I then go back and find the area? Is to integrate. So this then becomes the integral of the y that we've got there. And if we've got y equals a function, then the area is the integral of that function of y. The textbook goes through it a little bit as well, so feel free to have a look through that. But essentially, we're then going to be finding definite integrals for the area underneath curves between 2 points. So as long as I know these 2 points on the x-axis, and I know the function of the curve, if I just integrate the function of the curve between these 2 points, I'm going to find the area underneath that curve. This is just a bit of how it works. Hopefully that makes a bit of sense, and then we'll go through the examples in the next videos.